So welcome to online training session day 4 3D meshing. As we have completed day 1, that is FEM theory, day 2 1D meshing. In day 3 we have completed 2D meshing. Then on day 4, that is today, we are going to see how to do 3D meshing in HyperMesh. Then so on, accordingly we will proceed for the next training series. The topics which I am going to cover in today's training session is creating and editing solid geometry. That is most important to understand the behavior of solid geometry and edit them. Then how to create tetra mesh. That is, there are two options available in HyperMesh to create tetra mesh. One is direct tetra mesh, that is auto tetra mesh, creating a closed surface volume or a solid geometry and directly converting it into tetra mesh. Or the second option is doing the 2D geometry, enclosing that, and then performing the tetra mesh, then converting it into tetra elements. Then also we'll see in this tetra mesh option is how to perform the quality checks and how to improve the quality of the elements, of the tetra elements. Then we will see creating a hexapenta mesh using surfaces and creating a hexahedral meshing using solid map function. So these are the two more in hex meshing. Lastly, we will see how to use tetra mesh process manager for tetra elements, to create tetra elements. So we will start with this first tutorial as creating and editing solid geometry. In this tutorial, we will see how to what is solid geometry is, what is topology is, and what is 3D topology look like. So these are the things which we will cover in this. So I will open this. Solid geometry.hm. You can see it in the line mode. If you click on here, this is the shaded geometry. You can also change it to mixed so that you can see the surface color as well as the edge colors. In the earlier tutorial, I've already discussed about the edge colors, like what does green means, what does yellow means, what does red means. So if you make it in a line mode, you can see there are no red edges. So my geometry is complete enclosed volume. You can see all the surfaces are having the green edges, so it's completely enclosed volume. So now we will start with creating surfaces, or we can start with converting the surfaces into solids. So if we have only surfaces, then how to convert them into solids, that we will see first. For that, we will go to geometry page, solids. In solids, we will click on 1, 2, 3, 4, 5, 6th option, that is bounding surfaces. Here it provides the option as surface. So if you click on surface, and if it's an enclosed surface geometry, then it will automatically pick all the surface. If not, I'll show you. I will just toggle one of this. So it is not now, it's not an enclosed. So again you can see, if I click on the surface, it's not picking. So it has to be an enclosed surface geometry. All the edges have to be green or blue. There should not be any red edges. So I'll again toggle it down. So now you can see it picks all. Then check the auto select solid surfaces, so it will automatically select the enclosed volume and create the solid. And you can shuffle it here from surface component to current component. So make it as the surface component, so it will directly go to the component in which the surface are. Or you can create a new component like solids. Give him a different color, create, and toggle it down to current component and say create. So now if I off this, my geometry will be in this component. So you can see. my geometry is in a different component like solids. So these are the solids. If the line, the red color, the green color edge, if you see it's bold, so that means they are solid. In surfaces, they are very thin. If they are, these green color edges are thicker, so that means they are solids. So as you can see, my solid has been generated. Now we will see how to create geometry cylinder using different options. So again, for this we will go to geometry solids, and in this we will select cylinder full. That is the second option. We will select this. I will make it in a line mode and select the first and second node. Enter the base radius as 1.5. I want to create a cylindrical portion of 3 mm dia, and the height will be 25. That is the distance between these two nodes. I have calculated it. I will again show you that from this to this, it's the distance, and say create. So once you click on create, you can see circular cylindrical portion has got created in HyperMesh itself. Then we will see how to subtract the cylindrical volume from rest of the part, that how to delete that. So for that we will go to geometry page, solid edits, and select the radio button as Boolean. Here we verify that operation type should be simple in bracket combine all. Then we will select the operation to A minus B, remove B from A. This operation we will select. As A, we will select the complete one. And the B one we will and select B as the cylindrical solid and click on calculate. So you can see it will get deleted. So we have created a cylindrical hole in this geometry. So in this way you can create different types of sections in the existing geometry in HyperMesh itself. Then we will see how to split the solid geometry using bounding lines. So we will go to trim with lines panel in the same, that is geometry, solid edit, trim with lines. So for this we will go to trim with lines panel. Then under the bounding lines, under this active bonding lines, you will select the solid. Then for the further process, we will select the line and we will select these lines and say trim. So once you click on trim, you can see that there are two different solids. One as this one, if we select this, so in this way we have trimmed these two different solids. So if I make it in a mappable, that I will explain you later what is mappable is. Then we will see a different option like with cut lines. Again we will select the smaller solid. And on this, so now you can again go to geometry, solid edits, pick this one, from this end to this end. We will create a cut line. So you can see it has created a cut line. Or you can select the solid and put the nodes from this to this and say trim. So in this way there are different options available to create the cut sections in solid geometry like we see in the surfaces. Now later on we will see how to merge two solids. That if we want to merge two solids, how to do that. For that we will again go to geometry, solid edit and click on merge. We will select to be merged this solid and this solid and click on merge. So once you click on merge, you can see it will merge these two solids which we have splitted. Then so these are the some options in HyperMesh through which you can edit the solid geometries with a different with different options, like creating the geometry and editing it by creating the cylindrical holes and splitting them into different solids. And if there are already many different solids, so how to merge them also, that also you can go with the same panel. So merge, boolean, trim with lines. So these are the options. With the solid you can convert it into surfaces into solids. So in this way we have ended with the first tutorial, that is what are the different options. Then we will move to the next one, that is tetra meshing. In this tutorial we will see how to perform volume tetra mesh, what is standard tetra mesh, checking tetra elements quality, and remeshing tetra elements as per the quality. So HyperMesh provides two methods of generating a tetrahedral element. The volume tetra mesher works directly with surfaces of solid geometries to automatically generate a tetrahedral mesh without further interaction from the user. Even with complex geometry, this method can often generate a high quality tetra mesh quickly and easily. The standard tetra mesh requires a surface mesh of tria or quad elements as input, then provides you with a number of options to control the resulting tetrahedral mesh. This offers a great deal of control over the tetrahedral mesh and provides the means to generate a tetrahedral mesh for even the most complex models. The tetramesh panel allows you to fill an enclosed volume with first or second order tetrahedral elements. A region is considered enclosed if it is entirely bounded by shell elements, where each element has material on one side and open space on the other. So we will look into this. I will click on new. Open the file of housing.hm. Again, we will click on this surface icon to view the surfaces. So this is my geometry on which I am going to perform the tetra mesh. So again, we will see whether it is enclosed volume or not. So I will off this and check there are no free edges and suppressed edges on this. So it's a perfectly enclosed volume. So now you can see here. Also, I will mask any one surface to see the inside area. So I will go to mask panel and mask this surface. So here you can see this is hollow inside. So these are the surfaces. So you can perform the tetra mesh on surfaces and solids. Again, I will click unmask all. So now we will start with volume tetra mesh to create tetra mesh for the cover, this portion. So to do that, we will go to 3D page. On 3D page, we will select tetra mesh panel to create tetra elements. In this panel, we will select volume tetra mesh. Select the entity as enclosed volume surfaces, because we have surfaces. If we have solid, we can select solids too. So as per my geometry, I will select it. So I will select surfaces. Click on the surface, and if it's an enclosed volume, it will automatically pick all the surfaces. As you can see here, it automatically picks all the surfaces. So same as the solid, if it's an completely enclosed volume, it automatically picks the surfaces. Then we'll verify that the 2D type is set to trias and 3D type is set to tetras from this drop box. We'll select the elements to current component. So it will move directly to the current component, that is cover. Then we specify the element size as 10. I will later on explain what is use curvature and use proximity. And click on mesh. So once you click on mesh, it will create a tetra elements. So if I off this geometry from here, you can see it has created the tetra elements. I will mask one of the element, mask and say reverse. So you can see this is the tetra element. If I make it in the line mode, changing the color to view it better, you can see this is the tetra element. So the software automatically creates the tetra element using the surfaces, or if I mask a portion of it, so you can see here it has created the tetra element. It has filled the surfaces completely. Now we will see some other options in the volume tetramesh panel. So here you can see it doesn't capture the curvatures perfectly. You can see here. Also the smaller region it doesn't capture perfectly. So here also the fillet region is not captured. You can see this is the mesh line and this is the surface. If I make it in a line mode, you can see it more clearly. So this we have some more options through which it can capture the surfaces more accurately. You can see here also. So the curved regions it doesn't capture perfectly. You can see for this one also. So what I'll do now, I'll delete these elements which I have created. And we'll see some other options like 2D as R trias, pick the surface, keeping all the other parameters as it is. We will click on mesh and see the difference. So you can see if you create an R tria mesh, the fillet region, the curved region, it captures more accurately as compared to the tria, because R trias capture the curved zones more accurately. So that's why it's always preferable to go for the R tria elements. I will click on reject. Again 3D tetra mesh, and we'll move to the next. So now we will see some more options in tetra mesh, volume tetra mesh panel, that is use curvature and use proximity. So what are these two? So if you check the box of use curvature, it will come up with the feature angle. That means it will help us to capture the curve features. Use proximity will help us to provide the range from minimum element size to maximum element or the average element size. So with these two options, if they are ticked and if you put a proper input here, so a better tetra mesh can be taken even with the auto mesh panel. So I will show you. I will use the minimum element size as 1. Feature angle I will keep at 30 degree. That is after every 30 degree normal to the element, it creates one more element. And we'll click on mesh. So it is creating the elements. As you can see, it is processing. Now you can see, if I make it in a line mode, so now you can see it has created a dense mesh around the fillets to capture them perfectly, and a coarse mesh around the planar surface because they don't require that much amount of elements. So it creates that in that manner. Also, if I change the average element size from 10 to 5, we will reduce it. Now you can see it also captures the fillets as well as it creates a good meshing around the planar surface also. So you can see the error margin around the fillets are very less here. So with these two options, if you check box these two options and put the inputs here, minimum angle and feature angle, minimum element size and feature angle. So by the auto mesh volume tetra panel, you can get a good tetra mesh elements. Also you can see here there is a surface deviation, so it captures the surface deviation too. So if I off this geometry, you can see quite a good mesh we have achieved. So now I'll click return and go to the hub panel where I already have the, I'll change the color. I already have the 2D mesh. What I'll do, I will just mask these elements. Also I will mask this face so you can see that. So this is hollow and I have a 2D surface meshed here. You can see that. So on the enclosed volume, I already have the 2D surface mesh. Elements by face. So now we will see how to convert this 2D mesh into a tetra element. So this is hollow. If I off this geometry, mask a portion of it, so it's completely hollow inside. You can see this. Now we will see how to convert this into tetra elements. So before converting it into tetra elements, it is always good or it's always suggested to check 2D elements quality first and then go further to convert that into 3D elements, so that automatically the quality of 3D element will improve. So we will first go to tools, edges, and check whether it is an enclosed volume or not, that the elements are enclosed volume or not. So I will drop down it to elements, select all the elements, say preview equivalence, and say find edges. So at the bottom you can see no edges were found. Selected elements may enclose a volume. If this message appears, that means your meshing is perfectly have an enclosed volume. So now you are ready to go to the next level, that is quality checks. So element quality checks, we will check for warpage, aspect ratio, it's perfect, Jacobian is perfect, minimum angle tria is also perfect, maximum angle tria, it's also perfect. So everything is perfect here, so that we can proceed to tetra mesh. So we will select 3D tetra mesh, but in this we will select tetra mesh, the first radio button, that is tetra mesh. There are two options to convert a 2D elements into 3D tetra elements. First is fixed tria chords to tetra elements, that is the splitting of these tria elements will get converted as same into 3D element. Or if you select float tria chord, so this splitting may be changed, means if in this scenario if the splitting is like this and during the tetra element quality check, if the splitting is something like this, it can convert it. So always it is suggested that if you are enough confident on your 2D elements that it is perfect, then only select the fixed tria and chord to tetra mesh. Otherwise you can select float trias chord to tetra mesh. So I will select this and click on mesh. I will also make it this as the current one, so my meshing will go to this one. I will on this and you can see here it has created a tetra elements. If I mask a portion of it, so you can see it has completely filled in. So in this way you can see on this one and mask a portion of this to a little more extent. So this is 2D outer surface, and inside you can see the 3D tetra elements. Now we will check the qualities of tetra element, and if required, how to improve that. We will also see that. So I will off this and check the quality of this. So again I will go to check the quality of the tetra elements, go to tools, check elements, or press F10 from your keyboard, that is the shortcut of check element panel. Select the radio button as 3D because we are going to check the quality of 3D elements. So first I have this 3D element also. So what I will do now, I will off this and delete this one because it may show the quality of that too. So I just want to see the quality of only hub elements on the hub. So in tetra elements, we'll first check the TET collapse. So generally the TET collapse value should be more than 3.3. TET collapse is the, just as I have discussed in the day 1 theory of FEM, it's the height of the element, it's the height of the tetra element. So it has to be more than 0.3, that is 30% of the actual one. So you can see around 5 elements are failing, which is having the tetra element, TET collapse as less than 0.3. So we will find them and solve them. So I will click on TET collapse to find all these 5 elements. Click on save field. Then click on mask. From the drop box, select elements. Click on the elements and select retrieve. So all those 5 elements which are failing, which I have selected in the quality check panel, will get highlighted here. We'll select reverse. To reverse those, we'll select all the elements other than those 5 and click on mask, so that on my GUI only those 5 elements are highlighted which are getting failed. So I will create the nodes from Shift F2. I can create the nodes here, and with this you can see these are the elements which are failing. So there are different options available in HyperMesh to improve the quality of the elements. So we will discuss one by one all. So I will press Shift F5 first. Go to Find Attach radio button. Select the elements and say Find. I will off this. So it will select all the elements attached to the element which is getting failed. So you can see here. Then again I will go to 3D, tetra mesh, and now we will see the tetra remesh panel. So I will select 3D elements and click on remesh. So there are 5 elements which are getting failed. So again I will press F10 from my keyboard and click on TET collapse. So now you can see earlier the minimum TET collapse value is coming as 0.19. So now it has improved to 0.26. So it has improved a lot. Or I will on all these and say TET collapse. So you can see without doing anything, my TET collapse value has improved a lot from 0.19 to 0.26. So I will save this. I will show you some other options to improve the quality of tetra elements further. So again I will click on save field, mask, elements retrieve, elements reverse, and click on mask. Shift F2 to add the nodes, and one by one we will see what are the options through which we can improve the quality of these elements. So it is having the TET collapse as 0.277, as you can see this particular element. So I will show you what are the options available in HyperMesh to improve the quality of this particular element. So the one way is we can use a translate command. So Shift F4 is the short key of translate command. We will select this node, define a plane, enter the magnitude as 0.1 and click on translate. So it will move a little bit. Then again press F10 from the keyboard and check. So you can see it has improved to 0.3. That is my aim, to improve it to 0.3. Again for this one too, as this is more flatter, so the one way is we can change the distance of it from 7 to 6 and then check the TET collapse value. It's 0.274. So again I will press Shift F4, pick this node, select this and change it. So it has improved to 0.33. So once I done with this, so I will mask it and press Shift F2 and click on clear all. So I have solved one, then the next. So first of all I will see what is the value of TET collapse. It's 0.26, so I will improve it. Shift F4, this node, through these three sides, F10, it's 0.28, or we can do one more thing, F4 and change this distance, say 4.3. Again press F10, it's 3.14, you can see here. So I will again click on mask this element, Shift F2 and clear these nodes. So we are left with these two elements. So this is also the same thing. Shift plus F4 to enter to translate command. F10, 0.338, again F5 mask, Shift F2 and clear this. Then the last element, first we will check, it's 0.29, so it's very less. Again we will select this. So we have to just increase the height of the element to improve TET collapse. So now you can see that its TET collapse value is 0.35. So now for all the elements, what is the TET collapse value we will see. So I will press Shift F2 and say clear all. Again go to tools, check element, TET collapse. So now all the elements are having the TET collapse value more than 0.3. So as per your convenience or as per your requirement of the model or the geometry, you can improve the value of TET collapse. In 3D tetra elements, the most important check is the TET collapse. In the same way, minimum angle can go to up till 15 degree, it's okay. Maximum angle can be taken as 130 degree. So it's within very quite range, so that's not an issue. So these are the TET collapse is the most important check for tetra element, because if the height is very less, so it's almost like 2D element, so it will not behave like a proper 3D element. So to make it behave like proper 3D element, it should have a proper height. That's why TET collapse is the most important check. So in this way we have ended with this tutorial. So we'll proceed to the next one. So we'll move to the next tutorial, that is creating a hexapenta mesh using surfaces. In this tutorial, we will see how to create solid using different functions, and we will see how to check and fix improper model connectivity. So I will click on new to discard this and open a new file, that is armbracket.hm. So these are the surfaces, they are not solid. So even with these surfaces too, we can create a solid hexamesh. So what are the different options available in HyperMesh to create it? We will see here. So I will make to the model browser and make this as the current, the base one. So I will hide all these apart from the base one. So I will make it only visible. I will start with the base one meshing. For the hex mesh, this time I am going to perform hexa meshing. That is brick meshing. It is also called as brick meshing. So with the surfaces, to create a hexa mesh, a manual hexa meshing, we will use 2D and different options so that we can drag it the 2D to create the hex element. So I will go to 2D auto mesh panel. And we will select the top face, two surfaces, that is one is L and the base surface, and click on mesh. I'll say reject and abort. I will make this as chords. Again select say mesh. So in this way you can see it has created the chords, but I only want the chords. So chords only, set to all and say mesh. So you can see it creates only the chord. The try elements has been removed. So I click return. So this is the 2D element. If I make it in a line geometry, you can see this is the 2D shell element. Now we will convert it into 3D element. So we will see how to convert that into 3D element. I will click return to exit the 2D auto mesh panel. Now to create layer of hex element for the base, we will go to 3D, element offset. On 3D page, we will select element offset. In this, we will select solid layers, radio button. We will select the elements to offset. These are the elements I want to offset. Specify the number of layers to be 5. So along this thickness, I want 5 layers of hex element along this region. So I have selected the number of layers to be 5. The total thickness we will specify as 25. That is the distance between this point to this point is 25. So we will select the total thickness as 25. Then click on offset positive. So once you click on offset positive, you can see it has created a hex meshing. If I mask a portion of it, you can see this. This is the hexa element it created. Okay, or if I mask any one element, unmask all, or I will select mask and reverse, so you can see this is my hex element. If I make it in a line mode, elements, or changing the color to view it more, so this is the hex element. I can also create the nodes, you can see here. So this is 8 noded hex element. If I change the order, 3D order change to second, select the elements and say change order. Again, if I enter the nodes, so this is the second order hex element. Okay, clear all. Again I will change the order, change to first element, displayed, and change order. So I will make it again in a blue color. So now we will move to arm curve zone, the next portion. We will see how to mesh that particular portion. So how to mesh a curved portion using hex element. So first of all I will press F5 from my keyboard, select elements. I will first mask the bottom surfaces. Elements by config type as hex 8 because I want to mask only the hex 8 elements, not the 2D elements. Click on this select entity and say mask. Then I will click on return. Again I will show you elements by config, select hex 8, click on all, select entity and say mask. So now you can see the 2D elements are only highlighted. I have masked the 3D elements. Then first to do the meshing of this particular component, we have to create a center node for this. To provide the angle or the radius, we need to create a center node of this curved portion. So to create the center node, I will go to F4, the distance panel, select 3 nodes, select any one curved edge and create circle center. So in this way I have created a circle center. Again I will show you, I will repeat the same thing. To create a center, the first segment of the arm can be meshed using spin panel. We'll use the spin panel to do the mesh. This requires a node to be selected as the center point of rotation. The node you create in this step will be used at the center point. To create the center node, you will use distance 3 node panel. So we'll go to F4, select any one curved line, left click on it until it becomes a box, and on the edge select arbitrary, select 3 nodes and then click on circle center. So it will create the circle center. To check, we will create one more as circle center. So you can see it has created the circle center. Now we will use 3D spin panel to create a hex elements along this curved portion, that is arm curved. So I will make it in a line mode. We will select spin element because we have elements. So I will select only these elements which I want to spin. Otherwise it will spin all the elements. We will specify the angle as 90 degree from this end to this end because this is the 90 degree angle. From the direction, we will select x-axis. If I put it in xy, so you can see we want to spin it with the x-axis, so it will get spin in YZ plane. That's what we want. Then at the base point, we will select this as the base point, that is the center of this curved portion. And on spin, we will specify 24, as we want to create 24 elements along this region, the 24 layer of elements along this curved path. So on spin, we will create 24 layers along this curved path and click on spin negative. But these elements move to this same component, so I will click on reject and make this as the current, and again click on spin negative. So you can see it has created a hex mesh. If I go to mask and mask this, so you can see with this option too, you can create a hex element. So there are different options available in HyperMesh to create the hex element. So it's an individual choice which option you want to use where. So these tutorials will help you to understand the different options behavior. Then again we will move to the next component, the next arm straight, to create the meshing for this. So up till this point we have done the meshing. So we'll move to the next component, that is arm straight. In we'll see one more panel. See, you can use single panel to create the complete hexa meshing on this. But we are, in this tutorial I am using different panels to show you that what are the different options available in HyperMesh, so that you have a variety of options for different types of geometries. So to create again to create the hex mesh, we have one more option as line drag or something like that. So linear solid, we have one more option as linear solid, where we provide from which elements to which element we want to create the hex elements. So what we do now, we have to create a 2D faces here. These are the 3D elements. You can see, if I mask this, you can see these are the 3D elements. So for the solid layers option, linear solid option, you have to provide 2D elements. You can't provide the 3D elements. So we need to create a face or a 2D structure or a 2D element here on this particular face. So I will go to Tools, Faces, select this component and click on Find Face. So this will help me to create the face. Then I will make this only this current one. So I will click on the elements, by face, say reverse and click on delete. So I'll off this. I will on this. Go to delete, select elements or go to mask, pick this element, elements, by face, mask, and delete the rest of the elements. So now I have the 2D shell elements over the hex element, so that I can use linear solid to drag. But to use linear solid, we require the elements on both the sides. So we require the elements here also. So we create a 2D element here from 2D auto mesh panel. Pick this, make it in a line mode and say mesh. But to use linear solid, the number of elements on the both side has to be same. So I will select this 444 and 333. So now you can see the number of layers or the number of elements on all the edges are exactly same. Okay, so then I will click on return. I will off this. Go to 3D, linear solid. Then from we will select this, to we will select this, and in N1, N2, N3 we will select these three. With this same one I will select the align one to this. It has to be exactly the same. For density I will select 12, so 12 number of 12 layers it will create, and click on solids. I will say reject and make this as the current and click on solids. So now you can see if I off this, it has created a solid element for this too. I will press return. So if I mask a portion of it and say reverse, so you can see it has created a hex mesh. So this is one more option through which you can create the hex mesh when you have two similar 2D meshing on opposite faces. So you can directly convert that into hex meshing. So now my face option is done, so I will off this. Then I will move to the next option. With the same, I will press shift, I will go to 2D, auto mesh, pick this surfaces, and say mesh. I will make sure that the number of elements here has to be same, so it has 1, 2, 3, 4 elements. It has 1, 2, 3, 4 elements. I will make it here 4. Also, here also we will make it same. So the meshing will look quite smooth. Also, we can increase the number of layers here. 4 is good. I'll make it as the make current. So with this, we'll go to line track. Or I will make it in a line mode. First I will project one node at the top so that it will be easy for me to pick the nodes along the edge. So we have one node here to pick. Similarly, I will project a node here. So shift F7 is used to project. This node I will say duplicate. To line normal, say project. So I will project this here. Then I will go to 3D solid map function. I will show you one more option. Here I will select general option as this. Source geometry as none. I don't want to provide the geometry. Destination geometry surface, and select the top surface. Then along geometry, I will select mixed. Then I will select the line. And select this line. Then we will select node by path. And select the node path from here. So we will select this as the node path. Then in the elements to drag, I will select these elements. I want to drag these. And click on mesh. So once you click on mesh, you can see it has created a perfect meshing. So if I off this geometry and on the meshing, so this is the hex mesh which it has created. Again I will click unmask all. So this is one more option, shift F2 and clear all the nodes. So these are the some options available in HyperMesh through which you can create these are the different options through which you can create hex mesh in HyperMesh. So if you do manually, so there are less chances of getting elements failure, but there is a connectivity issue about the elements, so we will see and correct them. So if I go to tools, faces, I will select all the components and say find faces. If I off this, keeping only the face, so it has to be hollow from inside throughout. So I will go to mask, pick all the elements on the one side and say by face and say mask. So now you can see it is not hollow from here. It is giving two faces. You can see here. So it should not show like this, so it should not create some faces like this, it should be through hollow. You can see in this portion it is providing the two faces, here you can see. So how to solve them? So I will again go to delete, right click on delete this, and again go to faces, say 0.1, preview equivalence, or I will deselect it and select only this region of element and increase the tolerance value, say preview equivalence, say return. Again I will go to tools, faces, click on find faces of these. Again we will check it has to be hollow inside. So mask, elements, by face, mask. So you can see some portion is now hollow, but some is still missing. So we have to equivalence all these. So we will again delete it. So to enter the equivalence value, we can select the length, or first we will mask them. This particular section we will mask it. Mask and say reverse, and then check the length. It's 3.4. So again, tools, faces. I will this time enter the value as 1. Preview equivalence, find faces. Or I will delete it and create the face for all. Find faces. If I off this, go to mask, elements by face, mask. So now you can see here, this is now completely hollow and it is perfect. So this portion has to be hollow or it's through. So it is now corrected. This is showing the edges because it has no elements here. So now this one is perfectly connected. Now my elements are perfectly connected throughout. So in this way you can check the element connectivity and improve that element connectivity also. Also there is one more option through which you can check whether your hexa mesh which you have created contains has the perfect connectivity or not. You can check that also. You can directly convert it into hexa. So I will create one more component here and go to 3D tetra mesh, and I will convert this to tetra elements. If it gets converted into tetra elements, that means my faces are completely connected and everything is perfect. So in this way you can check these options or these parameters to create a hex mesh for any structure you want. So these are the different options available in HyperMesh to create hexapenta mesh for the model. In this way we have ended with this tutorial, so we'll move to the next one, that is creating hexaedral mesh using solid map function. So now we will see how to create a hexaedral mesh using solid map function. In this tutorial you will learn what is solid geometry is, what is topology is, and what is 3D topology look like. Solids are geometric entities that define three-dimensional volume. The use of solid geometry is helpful when dividing a part into multiple volumes. For example, dividing a part into simple mappable region to hex mesh the part. So we will see how to perform the hexa mesh on this using mappable function. So I'll open the next one, next geometry, and checking it how to make it mappable. So by geometry editing you can make that part as mappable. If I make it as mappable region, so you can see. So there are different colors of mappable. If I go to visualization, you can see the colors. Yellow color means one directional, green color means three directional mappable from where you can mesh it. Blue color means it's ignored, it is not mappable, and red color also it's not mappable. So it has to be two colors only, that is yellow color and green. So by solid editing, the first tutorial which I have shown, through that you can create a geometry into mappable. So we will start the meshing if we have a complete mappable geometry, that without creating a 2D elements, directly we can create the hex elements. That I will show you how to create that direct hex element. So for that I will go to 3D page. On 3D page I will select solid mesh. On 3D page I will go to solid map. Select one volume radio button, that is the fifth option. On the along parameter I will enter the size as 1. Then I will select this solid. I will start with this solid and click on mesh. If you are seeing like this, if the elements come like this, so click on the shaded geometry. So you can see the elements in the shaded geometry region. So click on this icon to view these elements in the shaded geometry region. Sometimes it comes like this, so just click on it. Similarly, select this and click on mesh. So automatically it finds the connectivity and proceed to the mesh. Then there are some other options also through which you can create a 2D meshing, and then with that reference of 2D meshing you can use solid map function to create direct 3D meshing. So we will go to 2D, auto mesh, pick this, enter the element size to 1, mesh type as mixed, we will click on mesh, and in the element density or element size, element density will enter 4 and say set to all and say mesh. So you can see a smooth mesh pattern has been achieved here. Then I will click on return. Again we will click on return. Then again we will go to 3D solid map. Now we will see some other options, that is in one volume. And we will select the volume, this one. And toggle this to element size to element density and enter 10, that is the number of elements, and click on mesh. So you can see it follows the 2D mesh to mesh the region. So you can see here it has followed this for the top region, and rest it will follow the same. So in this way it has created, if I make it in the line mode, you can see. Okay. Then we'll see how to mesh the rest of the volume, that is rest of the solid elements. So I will select as this other solid. Element size, I will toggle it down to element size and enter the value as 1.5 and click on mesh. Also you can select multiple solids like this, and mesh them all at once. So these are the options through which you can perform hex meshing directly if your geometry is mappable. This option is only can be taken into account only if the geometry is mappable. If the geometry is not mappable, then you have to follow the step which I have shown you in the earlier tutorial. That creating 2D meshing and then dragging those 2D elements with the different options available. Also, I will delete it and say it on. I will on this geometry and we will pick all these and mesh at once. So if entire geometry is mappable, you can mesh the surfaces all at once too. So if I off this, you can see. So if I click return, so this is the options, different options available in HyperMesh to perform or to create hex meshing. Now lastly we will see, so in this way we have ended with this tutorial. I will click yes, new, and lastly we will see using TetraMesh Process Manager. So in this tutorial we will learn about using the TetraMesh Process Manager to import the geometry or HyperMesh file, clean up the geometry, organize the model, holes and features, establish a mesh size and pattern for the organized geometry, create a 2D mesh, clean up the 2D mesh, create 3D tetra mesh. So we will see this. So let's start this session. So the TetraMesh Process Manager, to activate or to initiate the Process Manager, click on Mesh, Create, TetraMesh Process, Create New. Enter the My Section name, select the working folder on which you want to save the file or the TetraMesh file. And then I will click on create. So it will create the process. The TetraMesh Process Manager is a step-by-step process predefined to start with importing the geometry or HM file till editing, till meshing, till quality check. Everything is described step by step. You can see the hierarchy tree. That first it is asking for geometry import. So we'll select the file type as HM because I have the HM file. Select the location where you have the file. So I have the file here. And click on import. So this will import the geometry. Then after importing the geometry, the next step is to clean up the geometry. As you can see, it has already directed us to geometry cleanup. So in this, first we will select the edge tools. We will enter to free edge, enter the equivalence with 0.25 as a tolerance value. So it will remove all the free edges, or equivalence all the free edges. Then I will enter to edge tool, and will click on isolate. So it should show you the message that no edges found for selected type, unable to isolate. That means my complete geometry is perfectly fine to proceed further. Then click on accept. So we'll accept this. Then you can see it automatically moves to a next panel, that is organize and clean up holes. In this, click on plus tab. On the first line, enter 3.3 in less than D, that is dia is less than 3. Enter 5, we will enter 5 in the second and 10 in the third row. Keeping all the parameters as it is, we will click on auto organize. So now you can see it has organized all the holes into different components with diameter ranging from 0 to 3.3. The holes having the dia range from 3.3 to 5. Holes having the dia ranging from 5 to 10, so that we can mesh it separately as per our requirement. So if I go to select this component, make it a little transparent so that it will be easily visible. You can see this. So it's divide all the holes into different components automatically. Okay. Then number of circumference elements enter, will enter 12 on each, and along longitudinal element size we will enter 1 for all. So along the circumference it will create 12 elements, and for this portion it will create the element size of 1 for the 2D meshing. Then click on accept. It will redirect us to a next option, that is mesh holes. So we will mesh the holes. Then click on, keeping all the parameters as it is, click on mesh all. So it will mesh all the elements. So now you can see this, it has meshed all the elements perfectly. So automatically it has meshed all the elements. You can also delete the mesh. From the drop box, you can change it to this and say mesh all to get another type of mesh which is not perfect. So always make sure I'll go to delete elements all and say delete. I'll select accept and select this regular mesh and say mesh all. So it meshed all the surfaces, you can see like this. Then click on accept to accept this meshing. It will move us to a next panel, that user defined features, organize and clean up the feature. This panel, it will automatically move to the next one. We'll click on plus, enter the feature name as faces. We'll select all these 5 flat faces here and click on proceed. It will ask for the destination component as group faces, so I'll click on move and then click on return. Again I will click on plus and enter the name as top holes, click OK, and then I will select the surfaces of the top hole. So we can differentiate the meshing with this. Say proceed and move. So we have created 2 more components, different components to do the meshing. So I'll click return. And we'll accept it. Then we will move, it directed us to organize and clean up fillets. So we'll click on components and select this component, say proceed. Enter the minimum radius as 0 and maximum as 5 and then clean up. Click on clean up. So it will clean up all the unnecessary edges to remove the fillets so that the mesh quality will improve. And click on accept to move to the next. Then it will redirect us to mesh the features. So in faces, you will select the mesh type as trias. Element size we will enter as 0.5. And for top hole, we will select R tria regular or R tria union jack. Enter the element size as 0.5 and click on mesh all. So it will automatically mesh all the surfaces, as you can see here. Then click on accept. So then it will redirect us to organize and clean up. We don't want to organize and clean up anymore. Everything is done. So I'll just click on accept. Mesh the remaining size, remaining portion with the element size 1. Mesh type as trias. Click on mesh. So it will mesh all the components, all the remaining surfaces. Then I will click on accept. Then it will redirect us to element cleanup. So we'll directly move to the element cleanup portion. So with this, we'll click on component and select all the components. Say proceed. Enter the appropriate features like minimum size to be less than approximately minimum size to be 0.25, maximum feature angle to be 60 degree and normal angles to be 150 degree. And then we will click on auto cleanup, so it will automatically clean all the elements. So it will show you the message like cleanup process performed on 36 failed elements, no failed elements remain. So all the failed elements, it automatically rectifies them and it make it perfect. So now we will click on accept and move to the next. And select this and say all and click on mesh. So it will start the meshing process. As you can see at the bottom, it is showing that it is doing the meshing process. So now you can see it has done it. So I will close it or move to the model browser. Make this as isolate only, and you can see it has created tetra elements or tetra meshing for the complete geometry with geometry editing and everything. So you don't have to move to different panels to perform different operations. With the process tetra mesh process manager, everything is synchronized. Everything is in synchronized way to help you better and perform the tetra meshing in the fast way. So in this way, we have ended with the online training session day 4, in which I have covered 3D meshing techniques and geometry editing. Thank you very much for attending this session. To improve our online training session, please help us by sharing your valuable comments, or if you have any doubts related to this, You can also ask us those doubts on edu-support@india.altia.com. So if you have any queries, any suggestion, anything related to this training series, feel free to contact us through edu-support@india.altia.com. Also, if you find anything interesting on this, let us also know that. Thank you very much.